So we've got two more sections to work on tonight. One I think is relatively straightforward. The other one's a little tricky and kind of longish. It's on quadratics, which we'll get to. But let's start out with section 6.4. And by the way, the black pens kind of ran out, so I'm going on whatever's left here. And there's some moderately good green ones and maybe a good blue one, and we'll see if it works out. This section is called linear inequalities in one variable. All that means is you're going to have, in some way or another, you're going to have a less than or a greater than or a less than or equal to or a greater than or equal to sign in there. And it's just going to be like a regular equation we've been talking about. Regular equation we've been talking about, except that it's going to have one of those symbols in it. Okay? As with a lot of the other word problem things we're going to do, sometimes you have to read an English phrase and then figure out what symbols it's actually talking about. And unfortunately, it's also sometimes ambiguous. But I would never take any points off if it was an ambiguous answer. For instance, if you have something that says x is at least 5, okay, that means that x, whoop, this green pen is not a good one. Hold on. X is at least 5. Let's try this one. A little better. That means that x is greater than or equal to 5. Right? So if you see somewhere it says x is at least 5, that means x is greater than or equal to 5. It can be 5, or it can be 6 or 7 or 8 or all the way up to infinity. So it's greater than or equal to 5. If you see something that says x is at most 5, it's kind of the exact opposite. X is less than or equal to 5. Okay? If x is at most 5, that means it goes all the way up to 5, but nothing greater, and everything below 5. Okay? X is between 3 and 5. This is one of the ones I think is a little bit ambiguous. But really, it's going to be like this. We're going to write it like this. 3 is less than or equal to x, which is less than or equal to 5. You could probably argue that the less than or equal and less than or equal could be just less than signs, because it could be between 3 and 5. Does that mean it can equal 3? Well, depends how you interpret it. But I would not take off points if you interpreted that this way or just less than on both sides. Okay?
Between 3 and 5, wouldn't it be 3 is more than or equal to x?
If it's between 3 and 5, that means 3 is less than or equal to x. You could also say like this. You could say x is greater than or equal to 3, and x is less than or equal to 5. But you can't write it any other. You can't write it with just writing x once, except like this. Make sense? All right. How about x is less than 5? That's a pretty easy one. X is less than 5. X is no more than 5. X is no more than 5. What's that one going to be? X is no more than 5. It's got to be less than 5, right? X is less than or equal to 5. Could be 5, but it's no more than 5. Okay? That's how we're going to write those symbols. Okay? Let's do an example, straight off the bat, an example word problem with these. Okay? Any people still writing these down? All right. I'll let you keep writing these down. Let me read the word problem to you. This is kind of like it's somewhat similar to the cell phone problem we did yesterday, but it's involving rental cars. Anybody actually under 25 in here? Yeah, youngsters. Can't really rent a car in some cases. What's that? You can't. If you're under, I think you have to be, most of the time you have to be 25, but if you're less than 25, sometimes, yeah, on military orders they'll generally let you do it. But if if you just want to go rent a car because you're in Disney World for the week or whatever, then you can do it if you're like 22. But sometimes they charge you an extra fee because supposedly you aren't as good a driver or something. But I mean, I wouldn't trust Nadia to drive anywhere. But all right. OK, so here's the question: a car rental company charges $100 per week and 25 cents per mile to rent a car. Okay? Same exact thing as the cell phone problem the other day. However, if you can spend no more than $330 on a car rental, how many miles can you drive? Okay? Okay, I'll write it down. I'll write it down. I'm just waiting for people to write these down. But the point is you can rent a car for $100 per week plus 25 cents per mile. Okay? You can only spend $330 though. And the question is, how many miles can you drive? Now, could you drive 1 mile? You would spend $100 plus 25 cents. Is that less than your $330 maximum? Sure. So it's going to be one of these inequalities. Because you could drive 1 mile, or you could drive some amount that we're going to figure out, the maximum amount, to spend exactly $330. Okay? Can I erase these yet? OK. How's it going, Amy? How's it going? Good. All right. OK. So let me just write down some of the details of that problem that I read to you. OK, the car rental company charges $100 per week plus 25 cents per mile. Okay? And the question is, how many miles can you drive? How many miles can you drive? Is the green showing up OK?
Yeah.
Not for you guys in the back. I'll try blue. All right. So I'm going to the exchange tomorrow. OK. All right. Like with many of these problems, let's pick a variable to use. Let's use x. We could use m if we wanted to for miles. Doesn't matter to me. Let's just pick x. OK. So x is going to be the number of miles. X equals the number of miles. OK. And so what we're going to do is we're going to rewrite the numbers here in terms of this inequality that we're talking about. OK. So the cost is going to be, and we're trying to find out the cost, because you can, oh yeah, I forgot to write down. Your maximum spending allowance is $330 for the car. OK? Sorry? 1 week. You're doing it for just 1 week. OK? All right. So here's what we're going to do. We're going to just write this down. We're going to say the cost is going to be $100, 100, plus 0.25x for the number of miles. OK? And that has to be less than or equal to 330, because that's the number of miles you go, or the number of the maximum cost that you can spend. OK? 100 plus 0.25x. Now, you solve this as if this was an equal sign. And there's one little trick that you have to do, which I'll talk about in a minute. But we don't need it. We actually don't need it for this one. OK? How would we start this problem pretending that was an equal sign over there? Subtract 100 from both sides. Subtract 100 there, subtract 100 there. We're left with 0.25x equals 230. And then what do we do? Divide by 0.25 to get rid of the 0.25. Right? And so, oops, I wrote it wrong there. I said an equals, so I forgot. Still less than or equal to. Okay? And now we have x is less than or equal to 920 miles. Okay? So could you rent the car? I once rented a U-Haul and drove 5 total miles, because I was moving between 2 really close places, but I still needed a truck. So I got it back, and the guy's like, "Did you even drive anywhere?" I mean, it was like a block away. It was, anyway. You could rent this car for 1 mile or 2 miles or 100 miles, but you can't go more than 920 miles, because at 920, this becomes equal to this, and that's your maximum. Okay, and we could check it if you want. Okay, 100 plus 0.25 times 920 equals 330. Well, is less than or equal to 330. OK, 100 plus, what's 920 times 0.25? 230 is less than or equal to 330. And therefore, 330 is less than or equal to 330. If you tried to do 101, or sorry, if you had to try to do 921 miles, this would be more than 300. It looks like it's more there. This would be more than 330. and you'd be over your budget. OK? That's how inequalities work. OK. Stupid green pen. OK. So, like I said, you solve inequalities just like regular equations. OK? You solve inequalities just like regular equations, except for one thing. Don't forget this. If you multiply or divide, if you multiply or divide, I in there. If you multiply or divide in an inequality by a negative number, OK, the inequality reverses. OK, and some people are like, what are you talking about? Let me show you what I'm talking about. OK, if you multiply or divide by a negative number. OK, let's just do a straight up example with no variables. Is -3 less than or equal to 5? Sure. OK. Can I multiply both sides by the same number? In equations, we can do that all the time, right? We can multiply this side by some number, multiply this side by some number. Let's pick -1. Just multiply this side by -1 and this side by -1. It's a negative number, right? OK. -3 times -1 is 3. I'll leave that for now. 5 times -1 is -5. What's true now? Is 3. 3 is now greater than or equal to -5. You see how doing the multiplying by a negative number swapped the inequality? You got to remember to do that. Okay, if you forget to do that, you'll do it incorrectly.
And that's just multiplying or dividing.
Just multiplying and dividing. Adding or subtracting, because if you think about it, if I added some number to this side and added the same number to this side, they're both going to shift in the same amount in the same direction. But dividing by this negative or multiplying by the negative switches the inequality. OK? All right. One thing we have to do is we have to learn how to graph these numbers on a number line. OK? So, for instance, let me write a little. I showed you this notation last night, but let me show it to you again. This notation is going to say x for x less than 3. In other words, x is less than 3. On a number line, 0, 1, 2, 3, -1, -2, -3. OK? I'll do 4 as well. What this is going to mean is we're going to have, on this number line, all numbers less than 3. So what this means, I'll try to use a green pen here. OK? Yeah. Oh, where'd this one come from? What's that? Don't ask any questions. Hey, that works well. Less than or equal to 3. Thanks. All right. Not less than or equal to 3. Less than 3. Now notice something. See how I put a little circle here on 3, and it's an open circle? That means that it's less than 3. OK? Not less than or equal to 3. If it's going to be less than or equal to 3, we would fill in that circle. OK, let me show you another one. All right. Oops. So let's try. Actually, I can go back to blue for now. All right, let's try. Oh, well, if I just make this x is less than or equal to 3, all I do is I fill in the little dot there. OK? All right. How about this? X such that 3 is less than or equal to x, which is less than or equal to 5. Okay? On a number line, 0, 1, 2, 3, 4, 5, -1, -2, -3, -3, -2, -1, 1, 2, 3, 4, 5. I'm going to write it a little bit bigger so we can all see it. How's this? I'll start 0 here. 0, 1, 2, 3, 4, 5, and 6. OK. For this one, 3 is less than or equal to x. So 3, right, less than or equal to x. And if it's less than or equal, do we fill it in? Yeah, we do. Less than or equal to 3, or 3 is less than or equal to x, all the way up to 5, which is also x is less than or equal to 5. There's your little number line. And you can just make it like that. That's how you would label that or graph that. OK? If I switched it to 3 is less than x, then this would just become a circle that's unfilled, like that. OK? OK, one more. X such that x is greater than or equal to 3. X such that x is greater than or equal to 3. I'm going to redraw it up here. Right? Greater than or equal to 3. So I start at 3. Do I fill it in? I do. And then I go this way, and I just do a little arrow up there that says it goes on forever. Kind of like what I did down here, an arrow. And that's all you have to do. Not too bad, huh? OK. All right. Let's try one of these inequalities. All right. Everybody got this one? All right. OK. 3x plus 5 is greater than 11. Solve and graph. Solve for x and then graph. Okay? I'll walk you through this. We want to get x by itself, so let's move the 5 to the other side. It's being added, so let's subtract. Minus 5, minus 5. We get 3x is greater than 6. We can divide by 3 to get rid of that 3 there. So we get x. Do we have to flip any signs here? Nope. Greater than 2. OK? And we just draw our little number line. 0, 1, 2, 3, 4. Greater than. You can squiggle it or whatever you want, but just so you know that you can tell that it's a line going this way. X is greater than 2. And there's your answer. You can check these. OK? Plug in 2. 3 times 2 is 6, plus 5 is 11. OK? Is 2 right on the edge there? 2 is actually a little less than, well, 11 is equal to 11. So 2 would be less than, or x would be greater than that. Plug in something else. Plug in 0. 3 times 0 plus 5 is just 5. Is 5 greater than 11? No, so that's why the 0 part's not filled in. OK? Let's try another one. Let's try 10. 3 times 10 is 30. 30 plus 5 is 35. Is 35 greater than 11? It is. So look, 35 fits on the number line out here somewhere. OK, that's how you check these ones. Okay. All right. Let's try another one. Let's try negative 3x plus 4 is greater than or equal to 9. Okay. Negative 3x plus 4 is greater than or equal to 9. I'll just write it down and not say anything. Thank you. Yep. Okay. 5/3 is bigger than 1 but less than 2, correct? So somewhere between -1 and -2, and it's actually going to be a little closer to 2. You don't have to get it exact, right? We're going to fill in the dot, and then which way are we going to go? X is less than or equal to. There you go. Okay. Now, notice we had to flip. It started out as a greater than or equal to, and we ended up flipping. And I made sure to remember by I wrote swap, and I put a little star there. I mean, just so you remember, that's the key to this one. Okay, and this is how you'd write it in that notation. You don't get the swap part? Remember how we did this? -3 is, well, 3 is less than 5, right? If I multiply this side by -1 and also this side by -1, which I'm allowed, what happens? -3 and -5. Is -3 bigger or greater than or less than -5? It's greater than now, so you had to flip it. Okay, whenever you multiply or divide by a negative number, flip the inequality. Okay. All right. Questions on this? Okay. There's one more type that we can do. Okay. One more type of these that involves some of that initial notation that looks a little funny. If you have, and you'll see a couple of these on your homework. Let's say we have -7 is less than 2x plus 5, which is less than or equal to 3. Now you've got some interesting stuff going on. Tip number 1, don't try to move the x outside the middle here. It's just not going to work for you very, very well. Things will get a little screwy if you try to do that. Might work out, but I doubt it. So just try to get rid of the stuff in here by doing both, whatever you did here, to both the left and the right. So it's like a little extra step. Not much harder, just a little extra step. So if I want to move the 5 out of here, what do I do? Subtract 5. I'm going to subtract 5 from here and from here. Okay? So you're going to get -7 minus 5 is -12, less than 2x, which is less than or equal to 3 minus 5, which is -2. Okay? And then you do what? Divide by 2. Do it for everything. And you get -6 is less than x, which is less than or equal to -1. Okay? And then you can write this like this, x such that -6 is less than x, which is less than or equal to -1. And you can draw this on your number line. Let's see, we've got to fit -6 all the way to -1. Let's say -7, 6, 5, 4, 3, 2, 1, 0, 1, 2. 2, -1, 2, 3, 4, 5, 6. There we go. OK, and we're going to go -6, open or closed? Open. -1, open or closed? Closed. And then we're going to fill in the middle there like that. Okay. You can check this one again if you want. Let's pick something in the middle here. -3. 2 times -3 is -6. -6 plus 5 is -1. Is -7 less than -1, which is less than or equal to 3? It is. Let's pick something that's outside this range. Let's say -10. -10 is down here somewhere. 2 times -10 is -20. -20 plus 5 is -15. Is -7 less than -15? No, so it's out here somewhere. Okay, -15 happens to be less than or equal to 3, but it doesn't fit in the range correctly. Okay. All right. Questions on that stuff? You'll see a lot of that on your homework to practice. Good? All right. OK. We are done with linear inequalities. It's a quick one. Now we are on to, try the green. We are on to, nope, the green's not working. Try the black. 6.4. I'm sorry, 6.5. That was 6.4, wasn't it? 6.5. OK. 6.5 is one of the ones that everybody goes, oh my gosh, I remember this from high school, and I don't like it. You'll like it once we get done. It's not too bad. Quadratic equations. Quadratic equations. Dun, dun, dun. All right. OK. Quadratic equations are equations that have an x squared or some other squared variable in it. OK? X squared term, but no higher powers. No higher powers. OK? Three x plus 5 is not a quadratic because it doesn't even have an x squared term in it. OK? This term is actually called, the 3x is called a monomial. Okay? Don't worry about the name, but I'll give it to you, and it'll make sense in a minute why we're calling it a monomial. 3x plus 5, this whole thing, is called a binomial. Okay? Another binomial is x plus 2, for instance. Two binomials. What happens when we multiply two binomials together? 3x plus 5 times x plus 2. 3x plus 5 times x plus 2. Okay? What does this kind of look like, the property that we talked about? It's going to become the property, the distributive property. We can actually distribute this across the x and across the 2. What would that look like? It would look like this. 3x plus 5, 3x plus 5 times x for this one, plus another 3x plus 5 times 2. And then what do you have to do to this? Let me rewrite it here. Does it now look like you distribute that through? 3x squared, because x times x is x squared, plus 5x. And we can do the same thing with the 2 here. 2 times 3x is going to be 6x, and 2 times 5 is 10. Are there any like terms here? The 5x and the 6x. So we're left with 3x squared plus 11x, because 5x's plus 6x's gives you 11x's, plus 10. OK, hotshots. If this is called a monomial and this is called a binomial, what do you think this is called? It's called a trinomial. Is it trinomial? Is it a quadratic form?
Yes.
It is, because it's got an x squared and no higher powers. OK? All right. Now, notice something else about this. Let me just erase this middle thing here so it becomes a little clearer what I'm about to do. OK? Nope, I didn't mean to erase any of this. 3x squared. OK? All right. The 3x squared came from this multiplied by this, correct? This is going to look funny if I try to do this like this, but OK. That would be the first term. The first terms, the 3x and the x multiplied together. OK? How about, let's look at this one. The 6x came from what? Let me do it in a different color, since I've got these colors here. OK? The 6x came from the 3x times the 2, right? OK? We call those the outer terms, or the outside terms. OK? From there and there. OK? How about the, let's try this one, 5x terms? Where did that one come from? The 5 and the x? right? The inside terms. Okay, the inside terms. The first terms, the outside, the inside. And then how about the 10? The 10 came from the 5 and the 2, right? Which is the outside, sorry, the last terms. Okay? I guess I should have written it 5x, 6s, and 5x. What we've just demonstrated is this thing called the FOIL method. The first, outside, inside, and last. Okay? So when you're doing, and I'm going to erase all the, and we're going to do another one because it's kind of confusing here. But we're going to use this FOIL method to figure out, to multiply these together without trying to do all the distributive property business. Okay? So let me, can I erase this now? People are still writing them? OK. I'll leave that. Whoops. So I'll leave that right now. OK, like this. Well, I guess the orange is hard to erase. OK. Let's use the FOIL method to do this, one. 2x minus 3 times x plus 5. OK, the first terms, 2x and x, 2x squared. The outside terms, 2x and 5, 10x. The inside terms, 3 times x, 3x. And the last terms, negative 3 and 5, negative 15. We've got two like terms we can combine. 2x squared and the 10x and the 3x combined to be 13x. And the final one is negative 15. Did I do it wrong?
Wouldn't that be minus 3 negative also?
Oh, thank you. You're right. Negative 3 and 7x. How's that? Better? Thanks for catching me. So I forgot. This one was a negative. The inside terms are negative 3 and x, so negative 3x. Good. Okay. And that's the trinomial. Okay. Now, notice something about this. Okay. These are factors of this. Okay. In other words, this times, it's like saying 7 times 4 equals 28. 7 and 4 are factors of 28, right? Multiplied together, they give you this. This multiplied by this gives you this. So these two expressions are factors of this. Okay? And as I said, this is a trinomial. This is a trinomial. Okay? OK. We can multiply these, and it's pretty standard, straightforward to go whoop and multiply this using the FOIL method. What we have to do is we also have to go backwards and go from this and get the two factors by themselves. Okay? There Nadia is going again, shaking her head. It's not as bad as you think. Okay? We have some kind of general rules. It's not as straightforward as just going boom and walking through the FOIL or something like that. It's a little bit more subtle than that. But it's not too terrible. And you practice this enough times, you get good at it. And I'm never going to ask you really hard ones. Okay? Well, maybe as a bonus or something. But I won't ask you a hard one like that's for regular credit. Okay? All right. If we have a trinomial that looks like this, let's take this one. X squared plus 4x plus 3. Okay? We're going to want to find the two factors, and the factors are going to look like this. So always just write down the two parentheses there, because you're going to have something plus or minus something times something plus or minus something, right? It's going to look like that. Okay? Notice something, and you can kind of use the FOIL kind of as your guide here. Okay? The first two terms, they're going to be multiplied together for the FOIL method, and they're going to give you this term. What times what gives you x squared? X. So that and you're halfway done almost. Right? Because you already got the x. You know that when you do the FOIL method on this, you're going to end up with x squared. So those two have to be x. It's going to be a little different if you ended up with something like this one. But we'll get to that one in a little bit. Okay? Notice something else. Okay? The last are going to be this one times this one. Okay? This one times this one has to equal what? 3. Okay? So you got to notice that multiplied, they have to equal 3. Okay? And when you add this and this, take a look at this one, right? When we add, well, that's not a good example. When you add this number plus this number, they have to equal what? 4, because they're going to get some factor of x plus some other factor of x, and you add them together and you get 4. Okay? When you add them, you get 4. This is the clue you're going to use to figure out what's next. Okay? All right. Now, you could have two types of this for the sign here. To get a positive 3, you can either have what are the factors of 3? Multiply together. What two things equal 3 when you multiply them together? 3 and 1, or who's saying 2? What could you get? 2 times what equals 3? Yeah, 1.5. We're only going to deal with whole numbers, okay, or integers, I should say. We're not going to deal with any fractions in these ones. You could think of fractions, but then it would be really difficult because I wouldn't give you, unless it was a bonus or something, I wouldn't give you ones that weren't complete integers. They weren't integers, okay? 3 and 1, but somebody else I heard it said -3 and -1 times each other also give you 3, because negative times negative is a positive. Okay, but which is the only ones of these that add together to get 4? 3 and 1. So you can put a 3 and a 1, and it's got to be positive and positive. Or it could be 1 and 3, but it's the same thing by the commutative property. This times this is the same as x plus 1 times x plus 3. Okay? You got to use those kind of thought patterns to figure this out. Now let's check it. First, x squared. Outside, x. Inside, 3x. Last, 3. X squared plus 4x plus 3. Check. Works. Okay? All right. Let's do a slightly more difficult one. Okay? Slightly more difficult one. Let's look at x squared plus 2x minus 8. X squared plus 2x minus 8. Try to factor that. Okay? Write the parentheses. It's a nice, easy one. What's the first terms have to be? X. Okay. The last two terms have to multiply together to make what? -8. Okay, let's write down all the factors of -8. 4 and -2. -2 and 4. What else? 1 and 8, or 1 and -8, or -1 and 8. Any others? OK, so our answer is going to be one of those choices. Right? It's going to have to be one of those choices. OK, let's figure out which ones it's going to end up being. When these add together, what do they have to equal? Positive 2. Which ones of these add together to get positive 2? Let's see. How about the first one we wrote down? Right? None of the other ones actually add together to get 2. So plus 4, -2. Right? What's that?
We have the same thing first.
I wrote it backwards, didn't I? Yeah. How about -4 and 2? Better? Yeah, thanks. I think I did the exact same thing last time I taught this. Oh, well. Because my brain works in the same way. OK, you can check it by doing the FOIL method as well. But that's going to be the answer. And if you'd gotten x minus 2 and x plus 4, same thing. So no biggie. Try this one on your own. X squared minus 6x minus 7. x squared minus 6x minus 7. Yeah. Is that what you got?
So that would be the final answer.
That is the final answer. Or x minus 7 and x plus 1. Here's what I did. I wrote down the x's first. And I said, OK, I know the x's are going to be there. Then I said, well, these two terms have to multiply together to get negative 7. So I wrote down the two factors that go into negatives that make negative 7. And then I said, added, they have to be equal to negative 6. So the only one that works is this one, because that would be added together to get 6. OK? You can also try this one. X squared plus 8x plus 15. This is actually a fairly easy one. Yeah. When you write down the factors, you can pretty much immediately get rid of the negative ones in here, because this is going to be positive 8. And if they're both negative, they can't add together to get positive 8. But you could also say, OK, well, which one adds together to get positive 8? 3 and 5. Done. Okay. All right. OK, those are the relatively easy ones. This one it gets a little harder when the leading coefficient is not 1. Any questions on this one, by the way? OK. All right. It gets a little trickier when the leading factor is not 1. Let me write this one down, and I'll erase the rest. 3x squared plus 5x minus 28. It also gets a little trickier when this has lots of factors, too. And sometimes it's just a matter of trying as many of the factors until you get it right. It gets really tricky if this has multiple factors too, but I won't give you any of those, at least not in a quiz. You might have 1 or 2 on the homework, but I don't think so. OK? All right. Here's how we do this one. You still have this first term here. So these two factors, or these two, the first parts of each term, or the first terms of each factor, has to multiply together to be 3x squared. Okay? In this case, it's pretty easy, right? It's going to have to be what? 3x and x. I suppose it could be negative 3x and negative x, but don't go down that road unless you have to. You generally won't have to. Okay? 3x and x. Okay? Again, the last factors have to be equal to negative 28. Now, negative 28 has a whole bunch of factors. Negative 1 and 28, 1 and negative 28. Okay? Negative 2 and 14, or 2 and negative 14, or 4 and 7. Oh, negative 7, or negative 4 and 7. Right? There's lots of those in there. Okay? But it's not quite as easy as just saying what adds up to this middle thing. it's going to be one of these times 3 plus the other one equals 5. OK? You could, there's a whole list on my sheet here of all the different ways to write this down. I don't know if you can see this. But there's a list of all the different factors. 3x minus 1 times x plus 28. 3x minus 1 plus x plus 28. And then you go 3x plus 28 and x minus 1, et cetera, et cetera, et cetera. And there's a whole bunch of them. OK, in fact, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. OK? I'm not going to write them all down, because this is one of those ones where you kind of start, you got to use some intuition in this to figure it out, and a little bit of just kind of guessing and checking until you get it right. OK, we know that the factors are going to be one of this choice, one of these pairs here. OK? And you're going to go down and you're going to say, OK, look, when I multiply 3 times one of these and add the other one, it's going to have to equal 5. OK, well, 3 times negative 1 plus 28, is that going to be ever equal to 5? No, it's not even going to be close. So this one's probably not either, because 3 times negative 28, right, is, or it could be, the other option could be 3 times negative 20, or 3 times 28 plus negative 1, which 3 times 28 is a huge number. So you're probably not going to worry about these ones, right? You could try them. You could try those 12 choices, but you could also just go down and check. OK, 3 times 2 is 6. Can you get a 5 when you add 6 something to 14? No. How about 3 times 14 is way too big when you're trying to add. So OK, so these ones aren't going to work. OK, you're left with these guys. OK, all right, let's see. 3 times 4 is 12. Can you get a 5 if you have negative 7 in there?
Yes.
Ooh, that looks like that might be a good choice. Let's think about it the other way. 3 times 7, 21, and then a 4. Can you ever get a 5 by adding or subtracting in some way? No. OK, so it's going to be one of these. And then so it's probably going to be one of these, and you're going to have the 4 multiplied by the 3. OK, so we're going to put the 4 over here like that. OK, and how are you going to do that? You're going to try to get positive 5. 3 times 4 is going to be 12. OK, and to get positive 5, you're going to have negative 7. OK, so would it make sense to go plus 4 minus 7? Yeah, that one actually is the right answer. Now, it takes a little bit of time to get that kind of intuition and to get that kind of going through it step by step. If you need to start writing them all out, go right ahead. Just know you're going to have 12 different choices here, right? If we had switched and we said plus 7 and negative 4, 3 times negative 4 is negative 12. And then plus 7, you're going to get minus 5. And it's not a minus 5, it's plus 5. So that's how you know that it's got to be minus 7 and plus 4. OK? Let's try another one. You guys can try this one on your own. I'll start to do it. OK? Let's try this one. 5x squared minus 24x plus 28. OK? Try to factor that. How's it going on you? No? Start looking at these guys and using your FOIL method and saying 5 times one of these plus the other one. See if you can get 24, negative 24. get this one, Aaron? Good. It's OK if you're stuck. This does take a little time, and you'll have plenty of time on the homework to look at these. And right after we get done here, have some time to look at these. Aaron, you want to walk us through how you figured this out? No?
Mine a different way. I don't want to confuse everybody.
Oh, you did a different way? Which one did you end up with?
Negative 14, negative 2.
OK, negative 14 and negative 2. OK. So what Aaron did somehow, his special method, I guess. If you have a good method, let me know, and maybe I'll teach that one instead. What he did was he said, OK, look, I've got to try multiplying 5 times one of these and then adding 14, or negative 14, or whatever, or sorry, adding the other one, I should say, to get negative 24. And he started going through and he said, look, 5 times 1 plus 28 or minus 20, you're never going to get a 24 there. It's close, right? 28 minus 5 is 23. That's close, but it's not 20. It's not 24. OK, so it's probably not these two. And then he said 4 and 7. And by the way, these are all the factors of the 28, because that's the last one. Then he said, let's see, 4 and 7. OK, 5 times 4 is 20. 27 or 13, that's not going to work. How about 5 times 7 is 35. 35 and 4, I'm not going to go either way. I'm not going to get 24 by adding any of those together. Then he said, OK, how about 2 and 14? 5 times 2 is 10. Oh, 10 and 14 does give you 24, right? OK, so this looks like one of these is going to be one of these. And you're trying to get negative 24. So he said, all right, 5 times negative 2 is negative 10 plus negative 14. So that's probably what it's going to be. It's going to be 5 times negative 2. Well, which one gets multiplied by 5? The final term here, like that, right? So let's do it like this, minus 2. And then it's also got to be the minus there. Let's see if that works out. First, FOIL, 5x squared. Outside, minus 10x, good. Inside, minus 14x. And then last, negative 14 times negative 2 is positive 28. And then this, when you add the like terms, you get 5x squared minus 24x plus 28. OK? So that's how I would do this. If it takes you a little longer to do, no worries. Just know that you're trying to do a couple things. Get the final term. It's got to be all the factors of those. And then you're going to try to, when you multiply the coefficient of this first term here by one of those and add the other one, you got to get the middle term in negative 24. OK? Relatively step by step, but it's not quite as easy as you might, It takes a little practice, I should say. OK? All right, let's take a break. Come back at 10 after. So the next thing we want to do is, now that we know a little bit about these quadratic formulas, quadratic equations, and quadratics in general, we can use the factoring method to solve a quadratic equation for x. OK? Take a look at this. OK? ax squared plus bx plus c equals 0 as long as a is not equal to 0. And the reason that's the case is otherwise then it wouldn't be a quadratic, because that would be 0, so it wouldn't be a quadratic. So ax squared plus bx plus c equals 0 is what we call a quadratic equation. Okay? We can solve quadratic equations if we have whatever the x plus 2 and x plus 3 equals 0. If we solve this for, it's not obviously because they're a's and b's, but if we get the two factors, here's what we can do. Isn't it true if two numbers are multiplied by each other and they end up being equal to 0, either one of them has to be equal to 0 or the other one or both have to be equal to 0. That means that if we get these equal to 0, we can then say, let's pretend one of them is equal to 0 and solve for the other one. OK? Or rather, I said that backwards. Let's pretend that one is some number other than 0, pretend that the other one is the one that's equal to 0, and solve for that. In this case, it would be x plus 2 equals 0. What's x have to be in this case? Negative 2. X equals negative 2. And then we could have scratched this one out and left the x plus 3. If x plus 3 equals 0, then x equals negative 3. So I'll walk you through an example of this as well. But what we're going to do is we're going to first factor the quadratic, and then set each one equal to 0, solve for it, which is really easy, and then you've got two answers. Quadratic equations always have two answers. OK, it's by their nature. OK, and we'll see why in a little bit. Actually, I'll just show you right now. We're going to go into this in a little bit, like next week or the week after. If you were to graph a quadratic equation, they all look like this form. What is that? It's called a parabola, actually. Not a block. This is a parabola. It could be it could be the other way too. Okay, if it keeps going on forever. Okay. Notice that if you take a value here, there's a value there and there's a value there that are both they both end up being the value for x, right? They cross the two places there. Okay. We'll get to more of those details later, just so you know. Now, what we have to do is we have to practice some of this solving of quadratic equations. Okay? All right. There are a list of steps on page 365 in your book. If you want to look on those, if you want to look at those, you can. Obviously, you don't have to now. But let's try an example. Keep in mind, the form of this equation is something squared, ax squared plus bx plus c equals 0. That's the important part. So if I gave you this and I said x squared equals negative x plus 6, and then I said solve for x. Okay. Do you guys ever see the joke? It's like Pythagorean theorem, x and like 4 and 5, and it says find x. And somebody goes, here it is. That's the answer, right? Here it is. Right? Yeah. So we are going to solve for x. We're not going to find x. OK. So in this case, is this quadratic equation in the right form yet? No, we have to get it equal to 0, which means we have to move everything over here to the other side. OK? We can do that by adding x minus 6. X squared plus x minus 6 equals 0. Now it's in the right form, correct? Did you see what I did? I did the two steps at once, basically. I said add. First, you could say I'm going to add x to both sides. OK, add x to both sides. Then I'm going to subtract 6 from both sides. I just did it all at once. OK? This is the form we're going to do. You guys are all pros now at factoring this. I'm going to leave the equals 0 in there. We're just going to factor this. This is one of the easy ones. I like that. Negative 3 and positive 2. Is that right? I think it's going to be positive 3 and negative 2, right? Because it's got to be x3 has got to be 3 minus 2 equals x, right? OK. All right. Now that we've got this, we use that special property that says if a times b equals 0, either a is equal to 0 or b is equal to 0. So we take both of these in turn, and we say, first of all, x plus 3 equals 0. Therefore, x equals what? negative 3. There's one answer. And the other answer is going to be x minus 2 equals 0, or x equals 2. Add 2 to both sides, you get x equals 2. There's your other answer. Okay? We can check this. Let's check both of these answers and see if they fit. Okay? Do them for this one, for the main one right here. Okay? Let's see. If we plug in 2, we're going to get 2 squared plus 2 minus 6 equals 0. What's 2 squared? 4. 4 plus 2? 6 minus 6? 0 equals 0. That works. Let's try the other one. Let's try negative 3. Negative 3 squared, and I got to put the parentheses in there, plus negative 3 minus 6 equals 0. Okay? Negative 3 squared is 9, plus negative 3 minus 6 equals 0. 9 minus 3? 6 minus 6 equals 0. 0 equals 0. Check. So you see how both x equals 3 and x equals negative 2, or sorry, x equals negative 3 and x equals 2 are the two answers for this quadratic equation. And we did that. We solved it by factoring. Okay. All right, here's another one. People still writing this one? No? OK. All right, the next one is 5x squared. Oh, this looks like an ugly one. 5x squared plus 54x plus 40 equals 0.
5x squared.
Thank you. 5x squared. Yep. Plus 54x plus 40 equals 0. Gold star. Another gold star. All right. Yeah. Sorry? Nope, I don't know why I put that in there. 1 times 1 and 50. Better? No, 40. I don't know what I'm doing. How about 1 and 40? There you go. Another gold star. OK, so this one's another one where you just got to figure it all out. The nice thing is it's all positive, so the odds are it's all going to be positive, right, when you do all these factors. OK? So let's see. 5 and 5 times 1 is 5 plus 40. You can't get 54. 5 times 2 is 10 plus 20. Can't get 54. 5 times 4 is 20 plus 10. Can't get it. 5 times 8 is 40. Can't get it. How about the other way? 5 times 40 is way too big. 5 times 20 is way too big. 5 times 10 is 50. And 4, aha, we're looking for 54, right? So it's probably going to be this one. 5 times 10, meaning the 10's got to be over there. And the 4's got to be there, and they're both positive. OK? Again, it's going to take some time to figure those out, to work through this, but you'll be able to figure it out. OK? OK, now, we've got it in this correct form. We say it's equal to 0. We set each one equal to 0. 5x plus 4 equals 0. And we get, let's see, subtract 4 from both sides. 5x equals negative 4. Divide 5 by both sides, or divide both sides by 5, and you get x equals negative 4/5. OK, that's one of them. The other one is x plus 10 equals 0, and x equals negative 10. I'll tell you right now, a bunch of you guys are going to look at this and say, oh, x equals 10. Because you see the 10 there, when x is actually equal to negative 10. Because you got to move it over. When you do x plus 10 equals 0, oh, that means x is actually negative 10. OK, but here's our two answers. OK, we would write this like this. We would write the little curly braces, and then we would write negative 4/5 and negative 10. Like that. OK. OK. Questions on that?
Why is the multiplication on the 10, why does that go to the right side?
Why does the 10 go over here, you mean? From the, oh, OK. So when we're trying to figure out the factors here, we know that it had the two factors of the last terms have to equal 40 when you multiply them. So it's got to. So we figured out as one of those. Then we said, look, we were trying to add 5 times one of them plus the other one to get 54. We figured out that 5 times 10 plus 4 is that. Well, when you're doing the FOIL method, you're doing the first, which is what? 5 times 10. That's what we're looking for. Right? Or sorry, the first outer, rather, 5 times 10. That's what you're looking for. And then the inner, 4. 5 times 10 is 50. 4 times 1 is 4, 54. That's how you know. It couldn't be over.
On the outside.
It's always going to, well, if that's the one you're multiplying by this one, it is, sure is, yeah. Because you never multiply, notice you never multiply the 5 times 4. There's no distributive thing there that you do that, OK? All right, questions on this? OK. All right, so now we've got now we know how to do this with factoring. But what happens if you can't factor the quadratic? Sometimes you just can't do it with integers. It's not going to work, OK? Well, we have this thing called the quadratic formula. Dun, 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 right? The quadratic formula. The quadratic formula, we are not going to go into how to derive this. It's a little tricky on how to derive the quadratic formula, the thing I'm about to write down for you. But just so you know it, if you want, I'd be happy to walk you through how we end up with this formula. But here's what it means. If you have something in the form of ax squared plus bx plus c equals 0, you can immediately, and I say immediately, but really it's going to be a couple steps, solve for x with the following equation. X equals, and this will bring back some memories for some of you guys, x equals negative b plus or minus the square root of, remember this now? Maybe it won't. Maybe it's not bringing back any memories. Yeah, you're close. You're close. B squared minus 4 times a times c, the whole thing divided by 2 times a. OK. Here, guys, did it bring back any memories? No. OK, fine. Then no memories. This is a true statement. What you do, this is actually much easier than it looks, OK? Here, first of all, the plus or minus. When you take the square root of 25, we always say that that equals what? 5. But doesn't it also equal negative 5? Because negative 5 times negative 5 also equals 25. OK? So really, we could write this as plus or minus in the sense that it's going to be either 5 or negative 5. OK? All right. So here's how we're going to do this. OK? And by the way, what this is actually kind of a simplified form here, because really this means negative b plus the square root of b squared minus 4ac divided by 2a. And it also means, comma, negative b minus the square root of b squared minus 4ac divided by 2a. OK? No, not positive.
No. You're right. Sorry.
Not positive b here. No, the negative's either there or there. Remember how quadratic equations always have two answers? Well, this is one of the answers, and this is the other answer. OK? All right. OK. So what we're going to what we're going to do is we're going to use this to solve some of these equations. Okay? Keep in mind, you have to have the 0 on one side for this form. Okay? All right. Here's what we're going to solve. Oh, did people still writing this one down? Sorry. This, by the way, this x equals this. You do have to memorize that. It's not going to be on your formula sheet. We'll use it enough that you'll figure it out, but just memorize it. This is not as hard as you think. Once we do it 1,000 times. What? No cheat sheet, but you do have a formula sheet that has a number of formulas. It does not have this one on it. You can immediately write this one on it if you want, but it will not have it on there, and you can't bring any extra notes.
That's for the final exam you're speaking of?
Yes.
Oh my God.
Don't stress about this. Don't stress about this. Here, I'll write it up here. X equals negative b plus or minus the square root b squared minus 4ac divided by 2a. OK. I'm going to write it right there, and we're just going to leave it there. OK? All right. So raise your hand if you've never seen that formula before. Huh. About 3/4 of you. OK. It's all right. Should have learned it way back in high school. That's OK. I'm surprised. Actually, a little surprised. OK. Here's the question. X squared equals negative x plus 6. OK? We did this one before by factoring, right? Is it in the right form? No. Add x minus 6 to both sides. You end up with x squared plus x minus 6 equals 0. Now, we know from doing this before that we could factor this. And this is x minus and plus. Let's see, x minus 3, or x plus 3, x minus 2. So we know that x equals negative 3 and x equals 2. OK. We're looking for those answers in the end, right? Did I do that right? No, sorry, I did not. Wait a minute. Did I do that right? Negative x plus 6. Yes. OK. So it's written down wrong in my notes here. There, now it is. Now it's written right. OK, so we're looking for those two answers. All right. This is in the right form for ax squared plus bx plus c equals 0. In this case, a equals the coefficient of this. What is by definition right there when you don't write it? 1. A equals 1. What's here? B equals 1. And what's this? Negative 6. C equals negative 6. Okay? All you have to do, if you have this memorized, is plug those in and then chug away until you get the final answer. So let's do that. X equals negative b. Well, b is 1, so you're going to write negative 1. And then you're going to write plus or minus the square root of b squared. That's 1 squared minus 4 times a is 1 times c, which is negative 6. And then the whole thing is going to be divided by 2 times 1 because a is 1. And now you just do this. Now you just start cranking through. X equals negative 1 plus or minus the square root. OK. What is negative 4 times 1 times negative 6? 24. What is 1 squared? 1 squared plus 24 is 25. OK? 2 times 1 is just 2. OK? All right. Square root of 25 is 5. OK? So we're now going to have x equals negative 1 plus or minus 5 divided by 2. We can split this up. Let's do the plus one first. Negative 1 plus 5 is negative 1 plus 5? 4. 4 over 2, or 2. That's for the plus part of it. If we do then, I'll do it over here. Negative 1 minus 5 divided by 2 equals negative 1 minus 5 is negative 6 divided by 2 equals negative 3. There's our other answer. Did we end up with 2 and negative 3. And that's what we started with? We did. Okay, so this stuff works. Okay, and when you see the notes online, you'll know that they're wrong because it doesn't have the negative 3 on there. Okay, let's do another one. Okay, any questions on that one? Okay, remember, you got to memorize this. And you'll do enough on the homework to memorize it. And I'll remind you to memorize it before next week's quiz, which is next Sunday. No, there's just one more quiz after that, and then the final. So I think the syllabus actually says there's one more quiz on like the last weekend, but I'm not going to do it. 3 quizzes instead of 4. Okay. Okay. 5x squared plus 54x plus 40 equals 0. Okay. All right. We could do this by factoring. In fact, we did before, but let's do it without. I'll remind you that the answers were negative 4/5 and 10. Okay, those are the answers. Okay. Negative 4/5 and 10. All right. What's A in this case? 5. What's B? 54. What's C? 40. So we start writing x equals negative b, negative 54 plus or minus square root of b squared. You need your calculator for this. 54 squared minus 4 times 5 times 40. The whole thing divided by 2 times, times 5. 2 times 5. Okay? All right. X equals negative 54 plus or minus. Now, here's where you do it on your calculator. You get out your calculator, and you say 54 squared minus 4 times 5 times 40. And you get what? 2116? 2116 divided by 2 times 5 is 10. And then you take the square root. To do that on your calculator, if you hit the second square root button, and then you can type 2116, or you could just type second answer. There's a little A and S button, at least on mine there are. Some of the other ones, there's actually just an answer button on there. Makes it nice and easy. And it ends up being 46. X equals negative 54 plus or minus 46 divided by 10. Negative 54 plus 46 is what? Negative 54 plus 46, negative 8 over 10, which equals negative 4/5, which indeed is one of our answers that we got before. Okay? Or you do x equals negative 54 minus 46, which is negative 100 divided by 10. X equals, sorry, what did I do wrong there? That is wrong. Did I write down the wrong answer before? Yeah, I did write down the wrong answer. Negative 10 was the wrong answer. The notes are wrong again. There we go. Okay, so negative 100 divided by 10 is negative 10, which is the answer we got before. Okay, see how this works? You write the equation down in the right form. You pick off the coefficients for A, B, and C. You plug into here, and you crank away. A lot of people mess up on this part. If it's a negative here, they forget that it's negative, negative, and they end up adding or subtracting wrong. And then they end up with something like square root of negative 11, which we all know is what's imaginary, right, or undefined. So you can't do it. So if you end up with something like that, redo. Okay, question, Rob?
Like the third step, where x minus 54 plus or minus 46. Third one?
Yeah. I did this. This is, so you have negative 54 plus or minus square root of 2116. I took the square root of 2116. And that equals 46. And then you're left with this part. And once you get to this part, then you have to break it up into the two different answers. Okay? All right. Let's do one where you could factor those ones before. Those were factorable into integers. Okay, let's try it without factoring. Okay? Let me do another one here. Can I erase the rest of this? Okay. All right. Remember, it's on the notes and on the video. Okay, here's one you can't factor. 2x squared equals 8x minus 5. 2x squared equals 8x minus 5. Is it in the right form? Negative. So we put it in the right form. We have to subtract this whole thing from both sides. Negative 8x plus 5. Negative 8x plus 5. So we get 2x squared minus 8x plus 5 equals 0. Now it's in the right form. What's a equal to? 2. What's b equal to? Negative 8. You got to be careful on that. And what's c equal to? 5. Okay. X equals negative b. So it's going to be 8, because b is already negative, so it's going to be 8. Plus or minus the square root of negative 8 squared, positive number, minus 4 times 2 times 5. The whole thing divided by 2 times 2. Okay? 8 plus or minus the square root. OK. 64. Write it down here, right here. 64 minus 4 times 2 is 8. 8 times 2 is, sorry, you're right. 8 times 2 is 16. I meant 4 times 2 is 8. 8 times 5 is 40. So minus 40. 64 minus 40 happens to be what? 64 minus 40, 24? 24. Okay? So we have square root of 24. Whoa, that's a loud phone. OK. All right, so 8 plus or minus square root of 24 divided by 4. Can you take the square root of 24? You can't. Now, we can simplify this. OK? You can simplify this to be, let's see, what goes into 24? It's a square? 4. How about 4? 4 times 6. Yeah, and that's the only one you can do. Right. 4 times 6. So this is going to be equal to 8 plus or minus, let's see, 2 square root of 6 divided by 4. You don't have to simplify this. In fact, it might not even have mattered if you simplified this. OK? But we're now going to actually have to plug in here and do it. So let's do the addition one first. 8 plus 2 square root of 6. 8 plus 2 times the square root of 6 divided by 4. Do that on your calculator. Since you can't do it using just regular old arithmetic, it's easier on your calculator. 8 plus 2 times square root of 6. Hit equals, because this whole thing has to be done before you do the divided by 4. Then you divide by 4, and you get 3.22 or whatever. Okay. By the way, you know what? I guess you could just leave it in this form if you want. We could do it all out, but we could just leave it in this form. Okay. And then you'd have 8 minus 2 square root of 6 over 4. For homework, you may have to simplify this. Notice how 8 divided by 4 is an even number, or it works out. And then 2 divided by 4, you can simplify that. So this would really be 8 divided by 4 is 2 plus square root of 6 over 2, because 2 divided by 4, the 2 ends up in the bottom. And the other one would be 2 minus square root of 6 over 2. Now, that's the way the homework will probably want it, unfortunately. Give it 1 or 2 shots, and then if you don't get it, go on and tell me. Okay? Somebody told me earlier, I forget who it was. Rolando, maybe? Dominic? One of you guys told me earlier, and I fixed it. I changed your answer already. OK, so that's going to be the answer there. OK? And one of them is 3.22, and the other one's negative, or 0.77. It's not the answers. OK. Last one. We'll do a little example that's kind of a word problem. OK? Like 3 weeks ago, did you think you'd look at a board and you'd understand all this stuff on there? Now you do. You almost do. You will. By the time you practice it on the homework, you will. OK. This is on page 359. Page 359, an example on page 359. You don't have to look at this up. Or you can look it up later if you want. OK? There's a formula on page 359 for the normal systolic blood pressure. Sharifa can tell us what that means. OK? For the normal systolic blood pressure, P of a man whose age is A. OK? So in other words, the blood pressure, OK, blood pressure P for a man of age A. OK? And here's what it is. The blood pressure equals, that's what it should be for the normal range, normal number. 0.006 A squared, his age squared, minus 0.02 A plus 120. OK? If you were 0 years old, this model doesn't work for that, but if you were 0 years old, your blood pressure should be 0 minus 0 plus 100, so it should be 120. OK? The systolic one. Which one's the systolic one, the top or the bottom? Top. OK. 120, yeah. OK. So this formula is the one that if your age is A, this is what gives you what your normal blood pressure is. OK? It's just a model, like we talked about the other. Question is, find the age. We're looking for the age where your blood pressure is 135. OK? So what you do is P is 135. So you'd go 135 equals 0.006 A squared minus 0.02 A plus 120. We're trying to solve for A. Is this in the right format for the quadratic equation? Not quite. All we need to do is move the 135 to the other side, and it will be this equals 0. And you could flip both, and so it doesn't matter. OK? Subtract 135 from both sides. Okay? And you end up with 0 equals 0.006 A squared minus 0.02 A plus, I should say, minus what? 15. Is that in the correct form where we've got an A, a B, a C, and equal to 0? It is. What's A equal to in this case? 0.006. B equals negative, careful, 0.02. And C equals negative 15. OK? All right. What I'm going to do is I'm going to erase this so that we can do the quadratic equation, quadratic formula. OK? All right. It's going to be, I'm going to use capital A because that's what we're looking for. A equals, it's not the same as little a. Negative B, 0.02 plus or minus square root of B squared, negative 0.02 squared minus 4 times A, 0.006 times negative 15 divided by 2 times 0.006. OK, this is one where you would need your calculator. OK? It's actually not too bad. OK? All right. What you do is you would do this all out, okay? And you end up with, tell you what you end up with. 0.0, this is one, by the way. Notice this is going to be a positive number minus a negative. So this is also going to be a positive number. Okay? It actually ends up being, or minus, the square root of 0.00004 plus 0.36, or 0.36, divided by 2, well, 0.012. Okay. When you do all this out, you get this. And you can actually add this together, 0.360004. Okay? Did I have too many zeros? Yep, you're right. Thank you. 0.0004. There we go. Okay? You can do this on your calculator, and it ends up coming out to either 51.69 or negative 48.36. Which one's the correct answer? The 51.69, because you can't have a negative blood pressure. Right? So you just throw this one out. Okay? Okay, you just throw that out. So what's the age? About 52. There's your answer. Okay? How did I what? I did this out. I did 0.36 plus 0.0004. Take the square root, add it to 0.02, divide by 0.012.
How did you get the
Negative 0.02 squared.
Okay.
And then this is going to be 4 times 0.006, which is 0.0024, times negative 15, which happens to be 0.36.
I missed the step where
Yeah. Yeah, that's all. It's just a matter of all the steps. There's a lot of numbers on here. I just want to show you how the kind of problem you might see on the final, where you have to do all this math with all these numbers. It's not that bad, Amy. Don't worry. Nadi's rubbing off on you. It's not that bad, OK? All right. So we are actually done with the stuff for tonight. And here's what I'd like you to do. I will give you some practices. Again, this is the kind of stuff you practice either now or, there's only one sheet, one page, now or one stack, one packet. You can do some now. Remember, class technically ends at 9:30, so I'll be here till then. Do as much as you want now. Do the homework. And we will see you on next week. I'll see you Thursday. That's right. If you want to come in Thursday, you're welcome to. There will be oh, you know what? I should have given you the practice quiz for next week, shouldn't I? I'll put it online. OK? I'll put the practice quiz online if you want, and I'll hand it out Thursday.
Where would it be?
So, on the website.
On the
My website. Nope. My website. It's first day of class. Were you here the first day of class?
I was.
Yeah, I handed out a sheet that gave the website. It's this website.
I haven't looked at it yet.
Let me write it down. You haven't looked at it yet? It's got all the videos. It's got all the notes. Kind of a nice website, if I must say so myself. http://ecosimulation.com/chris-greg/math103. Okay, that's the website, all lowercase. Okay. Any questions? A lot of stuff tonight. I will grade any quizzes